Good morning, college. Today we are going to solve exercise 3.21 from the book Fundamentals of Electrical Circuit Sadiku. The first thing I recommend to solve this type of exercises is to do a visual analysis of the location of the sources and mark the currents based on that analysis. For example, if we observe, we see that there are two sources, an independent current source and a dependent voltage source. The dependent voltage source is 3 times 0 and we see that it is 0 in the voltage drop across the 1K resistor that is in this position. If I see it with the positive and negative mark from top to bottom, it is. I guess the polarity comes in this direction. Over here in this way the current comes through this resistance E. Already having this current, we can guide ourselves to mark the others. For example, the current from the independent source of milliamps E between this point and here has to go the other way. What occurs to me is that it is divided into two parts. The part comes this way and the other part comes this way. Here it comes this way A, and it comes to this point and joins this one again and they go down this side. So, now that we have the marks, we can give the names to the currents. I can call it 21. I can call it the current N2. Here is the same current and here I am going to call it the current N3. Ready. Now that we have the currents marked, we can do the node analysis. For example, I'm going to put it here at 20 and at node 1. That is, at this point I am going to mark the currents that enter and the currents that leave. So the currents that come out of this point are the current I1 and the current Y2 times 21 plus the current I2. That is going to be equal to the independent current of 3 milliamps and I am going to put it here 3 milliamps. Okay. Now EHH, the current I1 is going to be equal to the voltage across the resistor. If we look at the direction of the current and one goes to the right, it means that the voltage 1 is larger than the voltage V2. And if we look at the polarity of the dependent source that is here, it has a polarity to the right. Therefore V1V and this dependent source add up. So I know that versus 1 plus 3 times versus sub 0. This is added and subtracted versus 2 because each time this generates a tension to the right. This also and this creates an opposite force on. The two spines of the resistance. Well, the current I1 plus the current N2. The current N2 is the one that comes from here, which would be V1 V2 over the 4. So all of this represents the current I1 and this represents the 42. It's going to be equal to 3 milliamps. Okay. Okay. Now what I'm going to do is, let's notice that 0 weight, depends on the voltage drop across this resistor. So 0 is the voltage drop here, but it is the same voltage that from this point, which would be V twice 0, is equal to AV2. Because let's observe that this point says that the voltages of this resistance and this point is the same node this and this same node earth. So the same voltage V2 V1 plus 3 times the voltage versus 2 because it is 0. I changed it to V2 minus V2 over 2 kilometers. About 2 kilometers. And that's kilometers. Two good plus V1 over 4 kilometers minus v 2 out of 4 kilometers. Well, all of that is equal to 3 milli. Okay. Now what I'm going to do is operate everything I have. Everything that has v1, which would be this and this. And it's going to stay with me. If you want, you can verify it as 3 out of 4 kilometers from v1. More everything with a v23 over 4 kilometers of the v2. All of that is going to be equal to 3000 amps. 3000 amps. Now this, as we can see, there are 4 kilometers here. There are 4 kilometers. So what I'm going to do is multiply the entire equation by 4 kilometers so that I can eliminate this denominator. Then I multiply all this by 4. I would be left with 3 volts 1 plus 3 volts 2 equal to 4 times 4 times 4, and this is milliamps and this is in kilometers. Well, it's going to be 4 times 3, just 12. Ready. This would be my first equation. Okay, I'm going to delete. I don't need it anymore. Now, hey, I'm going to apply node 2. Minus B. I'm going to trace here. It says that current 1 comes from here and current Y2 comes from here. Enter at this point, it's going to be equal to the current. And 3, so I'm going to delete this. That is here, and I'm going to put in 3 that, and 1 and the 2 come in here. But now what comes out is the current and 3, so that current and 3 is going to be equal to the voltage V2 over 1 kilometer. If we leave this the same, because we already know that V1 is all this and V2 is all this and the current and 2, what a pity, then the only thing I want left is to operate algebraically, where I am going to have to hear V1 on 2 kilometers plus 3 times EV2 over 2 kiloohms minus V22 kilometers plus V1 of 4 kilometers minus V2 over 4 kiloohms. And what is here goes to the other side with a negative sign. It would be minus V 2 over a kilometer 2 is equal to 0. So if I operate everything that has V1 and everything that has V2, I will end up with 3 over 4 kilometers of V1 minus V24 kilometers of east equal to 0. I multiply by 4 kilometers both everything that is on this side equal to everything that is on this side, and I will end up with 3 V1 V2 equal to 0. This is my equation 2, and this is going to be my 2 equations with 2 unknowns, and the solution method can be whatever you want. They can even use the calculator for these types of equations. I'm going to solve it with MATLAB. Along the way, I teach them how to use MATLAB. I have here 3 and 3. Notice, I put here 3 space 3, which means the first row, semicolon, and the second row is 3 minus 1. 3 space minus 1. Now the equal part would be 12 and 0. Here, it would be 12 semicolons. The other 0 row would be this 12 and 0. So the solution is this variable that I called solution. You can call it whatever you want. It is equal to a against slash b, and I notice that it is 1 and 3. This is equivalent to AB1. This is equivalent to B2, B1, and B2. So the voltages would be B1. It is equal to 1 volt, and B2 is equal to 3 volts. That would be the solution for exercise 3.20. See you in the next exercise.